going to be doing a presentation today. A little bit about myself. I started this company in 2001 after spending about 15 years working as a service manager, repairing cranes and bucket trucks and digger derricks. So my knowledge started in the repair business, the mechanical business, and then grew into the safety business. Company I worked for prior was leasing all this equipment and needed to have a safety person, so all the managers in the company drew straws and I lost. I essentially got thrust into the safety business. I wasn't looking for it. So at any rate, fast forward, here I am. Who in here runs cranes? Who manages those that run cranes? Okay. All right. Well, that's a good place to start. I've been inspecting cranes. I was in the field for about 20 years, and the first 10 years of this business as well, on my own, I'm doing nothing but crane inspections. So I've had a little experience, and I'd like to share it with you. If you have any questions going through this, stop me. Put your hands up, stop me, and ask. If I know the answer, I'll give it to you. If I don't, I'll make something up. Just want to give you some confidence. All right. So let's talk about the frequency of crane inspections and the requirements. OSHA requires an annual or comprehensive inspection to be performed every 12 months, or at least every 12 months. There is occurrences when you're going to inspect a crane more than once a year. In heavy duty or severe use, you'll want to inspect the crane more frequently. The OSHA standards are the law. That's what we go by. But we also go by the ASME for mobile cranes, ASME B30.5. A little secret, I'm on that committee. I've been on ASME committees for about 20 years now. So this is what the frequency is dependent on: the activity, the severity of service, the environment the crane works in. Now, the annual inspection on a crane is required to be documented. And if it's used in construction, then a monthly inspection is required to be documented. Now let's take that a step further. We are a business, and everybody that we work for is the business. The business is going to consider safety first, of course, but has to consider liability second. And for liability's sake, if a manufacturer has a daily checklist for inspections on a crane, if that exists, and it does in most manufacturers, all of the newer ones, I'm sure it does, then that also has to be documented. Now, because of my long experience in this business, I've gravitated, if you will, to testifying in accident cases. I always have a few of them going on. And one of the items that appears in the case is the daily inspection. How do you prove a daily inspection is done if you have no documentation? So now we're not talking OSHA now. We've gone beyond that, and we're going to the lawyers. And this is what the lawyers are going to focus on. Believe me, this is a recurring item for me, and that I want to share with you. So if your crane or cranes have a daily checklist, then do the daily inspection. I say that even if they don't have it do it anyway. For safety, all right? A daily inspection on a crane can be done in a matter of minutes. All right. The items that you want to deal with can be done pretty much visually, and again, in minutes. Okay. Other items, and we're not going to get too deep into this. SAE, that's for Standards of Automotive Excellence. They will cover some of the manufacturing requirements for cranes. We as inspectors have to look at that and consider it when we do a crane inspection. One of the things that I kind of grew up with was the introduction of the LMI into cranes, the load moment indicator for computer, if you will. We have grown into where we test that every time we do an annual inspection. Because they go out just like any other kind of electronic equipment. So the testing them once a year is a good thing. And the way that we test it is with a load test. Right, so, and we go out, we measure, and we make sure that the LMI measures what the crane's doing properly. Is everybody familiar with that LMI, or have you seen it? Okay, good. In short, what the LMI does, typically on a crane, is it measures the length of the boom. That's done electronically. It measures the angle of the boom as well, and also done electronically. And it takes those two items to calculate how far the load is away from the crane. Because the farther the load is away from the crane, right, the least stable and the least load that you can pick up is there. So that's what the LMI does. When we inspect a crane, we ensure that it's reading the length properly, it's reading the angle properly, and then we measure out the radius, right, the distance from the center of the bearing to where the load lies, and make sure that the LMI is giving us that correctly. And then what we do is we put a big enough load on the crane and float it away from the crane to the point where the crane shuts down. And it, in a sense, is an overload. And we do all of that measurement as well. And that's how we test it on LMI. So I guess I kind of covered this already, didn't I? And this is what we are going to look at when there's an accident. We're going to look at those daily and monthly inspection records, annual inspection records, the maintenance records, all of that. We keep our records digitally, and that's something that I'll share with you. I'll even give you a free ride on our digital inspection at the end of the class for free. Okay, we're going to walk down. Now, this isn't my first time seeing it, but I've never done this before. It's all new. Okay, so telescopic boom inspection. The first thing we're going to do is check for the alignment of the boom. Now, this is a pretty simple procedure. What we'll do is we'll extend the boom and we'll make sure that the crane is level. And then drop the overhaul ball down right behind the truck. And make sure that it drops down right behind the truck. That gives us the first indication as to whether the boom is bent or not. Now that we have the boom extended, we'll drop it down to the ground, and we're going to look at the wear pads. All right, the wear pads should be just barely touching the boom. We're also going to look at the boom to make sure that there's no scuff marks on it, because the boom didn't take any kind of a hit. It may have ballooned out, and then you're going to see scuff marks from the wear pads. We're also going to make sure that the wear pads are there. occasionally they do get spit out. Now, some cranes, the booms are going to come out and need to be sequenced coming out all evenly, depending on the make of the boom. These booms have changed through the years. Some cranes now have what's called a pinning boom, where the booms will come out one section at a time, pinned into the one before them, and then the cylinder comes back, grabs the next section, and pushes that out. And some of the larger cranes have so many configurations that you can have with the booms in the way that they pin. The crane manufacturers are compelled to, in the event that they want to sell cranes, to make the cranes pick bigger loads and weigh less. To meet that challenge, one of the things that they do is they've gone to a composite shiv at the tip of the boom instead of a steel shiv. It saves them, I don't know how much weight it saves them, but it gives them the ability to pick up more with less weight at the tip of the boom. This picture here is the 600-ton DMAC with essentially plastic shivs. Kind of gives you pause, doesn't it? Part of our inspection is determining that the extension cylinder is not leaking, and it's something that you can't see. So in our inspection, what we're going to come up with is, if in fact there is a leak, is that there is oil coming out of the boom. You can't go any farther than that. It's something that's going to take the crane out of service, and it's going to require mechanical attention to determine what it is that's actually leaking. It may be the extension cylinder, but it may be hoses in the boom, or it may be a holding valve. There's different items that could potentially be leaking. When we are looking at the hydraulic hoses, we pay very careful attention to the hoses that may be in motion. So we're looking in the turret and up to the boom itself at those hoses, because they move. And they're the ones that are more likely to leak than any of the other hoses. This is the boom lift cylinder. And this is something that we have had meetings in the office with the inspectors to determine whether this boom lift cylinder is in fact leaking. And we have come up with, and this isn't an OSHA standards or an ASME, we came up with a protocol, and this is especially important in cold climates, that a leak is when the oil is actually running down the barrel of the boom, or if there's evidence that it has. In a cold climate, when you first extend a boom on a very cold day, you may get a drop of oil out of it, and then it may simply stop after that. But there's going to be evidence around the gland, which is the very tip of the barrel of that boom, that there was oil there, but it's not running down because it only happened that once. So we're careful not to call that a leak. Now, to test the boom lift cylinder pins themselves, what we do is drop the boom into the rest, and then pull down on the control to see if we can move the pins. Right. So if you try to further retract it once it's in the rest, if the pins are loose, you'll see them move. You'll see them walk. Now, cranes that have multiple winches will have a auxiliary boom tip, which has so many names in the industry. the Northeast, you see it called a rooster, but you go into other parts of the country, you see an auxiliary boom nose. Anybody have an idea why you would have more than one winch in a crane? What would the purpose be? No takers? All right, I'll tell you. One of the reasons you might have more than one winch on a crane is if you want to do a tip-up act. In other words, you're going to pick up something that was flat, and you could attach one rope to one end and one to the other end of it, lift it, and then tip it up. Okay? So that's one of the reasons that you'd have two winches. The other one is, when they set these up, they would typically put a load block, which you can see on this one, on one of the winches, and then simply have an overhaul ball on the other one. When you have a load block and you have multiple parts of line, you're running very slow. You're picking up more weight with it because it'll multiply the amount of weight that you can pick up. But it's also running slower because you're not pulling up one part of line, now you're pulling up four. And then you have the other one that's only one part of line, it runs quickly. So the crane operator has the option of using one or the other. If he's picking up a light load, then he can hook up to the line that's over the auxiliary boom tip. Now, this is a job that I did in at Mass General Hospital in Boston. And the job was to put an air handler up on top of the roof. This crane is actually parked right in front of the front door of Mass General. I was hired to come down to inspect the crane once it was assembled and before they did the pick. The job started at 5 o'clock at night, and I was hired to be there at 1 o'clock in the morning, and I got there at 1 o'clock in the morning, and I was way too early because they were still installing the jib. The inspection started at 7 o'clock in the morning, so just think of that. So they started at 5 o'clock at night, and it was the next morning at 7 o'clock, did the inspection. I stayed to watch them do the pick. They were done in 20 minutes. And then they're putting the crane back down and taking it apart. All that work for 20 minutes. But that's the way that job goes sometimes. This is a jib pin, and when inspecting a lattice boom crane, there's a lot of moving parts, and one of the parts that you have to pay careful attention to is these pins, because that's what holds the boom together. The pins are going to have holders in them, whether it be Carter pins or whatever they were designed for retainers. So for every boom, you're going to be doing all these pins aside from just inspecting the boom. So this is a jib tip, right? And to inspect something like this, you have to look at every single lacing, make sure it's straight, make sure there's no dings in it, in every single weld to make sure that they're sound. So you can imagine that this is pretty time consuming. And this is only one component. Each component on a crane like this has its own part number and serial number. We see each component like this as a separate machine to itself when we do an inspection. So an inspection for a lattice boom crane, our inspection could run into 600 or 700 line items. We'd like to think that we're doing it right. Every crane has to have directions as to what you can lift, and that's a load chart. The load charts have evolved through the years. This is a load chart inside an old crawler crane. And it's, some people, I know it may appear to be very daunting. I gotta tell you, the load chart's very simple. It's just a matter of reading out how much boom you got, length of your boom, your radius, and you come right down, and it's gonna give you the number for where you are. And it's all about radius. It's all about how far that piece is away from the crane. That number drops. You can be in a 200-ton crane. This is a 70-ton crane. But 70 tons is only going to be picked up when you're right at the crane. You may be at a 5-foot radius. As soon as you start moving away, that 70 tons drops dramatically. Right? So the farther away you are, the less you're going to be able to pick up. The newer cranes, because they have so many configurations, like ones with a pinning boom. That pinning boom could have dozens of different configurations, because you can extend the first one 46% and the second one 100%, or all of them 100%. So you have all these different configurations. You also have different configurations for your outriggers. Your outriggers could be spread 50% or 100%. And then counterweights, multiple counterweight configurations. And a counterweight is makes the crane essentially like a seesaw. So your center of rotation is here, your counterweight is here, and you're picking a load over there. And the amount of counterweight that you have here is going to dictate how much of a load you can pick up over there, much like a seesaw. Two people get on a seesaw, if one person weighs a lot more than the other, the seesaw is not going to work in the way that you'd like it to. But what is your answer? You got a heavy person here, a light person there, and this is the middle. And how do you make the seesaw function so it'll teeter?
Heavy person's got to move to the middle.
Right, heavy person's got to move in, right? And now it works. Crane's exactly the same way. Now the newer cranes may not have a chart like this at all. They may have a chart book. And the book could have hundreds of different configurations for this crane. And then the newer ones, and I know the standards have a problem with this, the newer ones don't have a book either. They've got it on a CD. And they plug it in and download it into the LMI, and all of the load charts are on the LMI. I had to defend this one already. All the load charts are on the LMI. So I investigated an accident, I testified in an accident, where the operator was cited for not having a load chart in the crane. And it was there, it was in his LMI, and you could bring up the load chart just like this, but now it's digital. So things have changed, they have evolved in the business. Since about 1992, I forget the exact date, 1992, cranes were required to have a 2-block warning device. Now, the name came from old maritime, where you had the cranes on a boat, where they had a block on the bottom with a hook and a block at the top, and they reeved between them. And reeving between them means that you're going to be able to carry more weight. So you had a lower block and an upper block. They took that technology and moved it to the crane. So what's at the boom tip is the upper block, and the lower block is where the hook is. There was a number of accidents that happened that drove OSHA to require that you have protection, so that you can't 2-block a crane. You can't run that lower block into the upper block, because a winch is strong enough to pull it right off. So the answer to that was they were going to put a switch at the tip of the boom with a weight hanging from it, so when the lower block comes up, it hits the switch and shuts the upper function off. So that protection means that you can't 2-block a crane anymore. Right? is our load test requirements. If you're going to do load test on a crane, first off, you're going to be familiar with the system operation and recommended test procedures. When we load test a crane, we're going to run it up to 100% of its capacity. So you can't make any mistakes. Because, when a mistake is made with a crane, in my experience, it's usually a big mistake. So we don't want to make any mistakes with the load test. So our load test is done in two stages. First stage is to determine that the LMI is reading properly. So it's going to read it's reading its length properly, it's reading its angle properly, and its radius. So we'll measure out the radius and make sure that it concurs with what's on the LMI. If it doesn't, we stop the load test until that gets corrected. Then we go to the load chart and get the appropriate amount of weight. With a larger crane, when you need to get 20,000 pounds of test weight, but something that may not be available where you are, because usually this is going to be done at a job site. So what we'll do is we'll shed one of the counterweight plates and use that as a test weight. So by shedding the counterweight plate, it puts us into a different load chart, and it gives us the ability to use the test weight. Counterweight makes a great test weight because the standards require that counterweight weighs minus 0 pounds plus 200 pounds. So it's going to be close to what it's stated on the counterweight itself. So we'll rig up a counterweight and we'll use that for a test weight. There's times when we have to load test cranes that don't have counterweights, and we have test weights that we can bring. We have a water bag that will hold 24,000 pounds of water. Once you got a source for it. That's typically done, I would say pretty much every time we've used our water bag, it's been on ships. So ship up board cranes that have the fire hydrants that will give us enough volume of water to fill the water bag up quickly. So moving on to our procedure, we first calculate where the crane should shut down, and we measure it out. And then we float that load out to that point. And you can, with a hydraulic crane, you can listen to hear it kick out. You usually hear it funk out. That's my term, funk. That's what it sounds like to me. So here's what our documentation typically would look like. We're going to document the boom construction, whether it's hydraulic, jib length if we're using one, the boom type, the telescopic typically, right? That's what we're talking about now. And then the length of boom that we're using for this particular test. So this would be the same thing that we do for test 1 and test 2. If we're using the jib for the test, we typically don't, but we can. Then we talk about the jib length, the type of jib. Could be an extensible telescopic jib, or it could be a lattice jib. And then the construction, typically steel. So here's other items that are going to be on there. On the main boom, the length, the manufacturer may have a code setting for it, depending on the manufacturer. If we're using the jib, the length of the jib, some jibs will offset, so the boom will go up straight, and then the jib could offset 15 degrees, 30 degrees, depending on the manufacturer and the setup. And the auxiliary boom tip, that could be considered part of the load too. Now this crane here has options as to how far the outrigger is going to get extended. All right. So This is also noted on the inspection report, whether they're fully extended, mid-extended, and now with the newer cranes, they don't all have to be extended the same. Right? The newer standards, we have written in the requirement for the cranes, the newer cranes that are being built, to have a way to measure the length of the beam of the crane. And then that will go into the LMI, so you don't have to guess. It knows that they are getting pretty sophisticated. So when you swing a crane around and you've got a short outrigger at one point, it takes and decreases your capacity. So I think that's pretty slick. And then the counterweights. And we do shuffle counterweights out there in the field. And, well, I guess I already covered this slide already, didn't I? Now, to locate a load, on the left here you see a 350-ton DMAG getting loaded up to its capacity with so 100,000 pounds of counterweights that we assembled. Took a little time to get them assembled. And this was a pre-purchase test, which in fact failed. The company that was buying the crane wanted the load test held up for an hour, and then what you do is you lift the load, measure how far it is from the ground, and leave it for an hour. They were using it for moving rail cars and mining based on South America. The crane didn't do it though, it failed. So that was the end of that inspection. Sometimes we're out in the field, it's hard to find a test weight, and we'll take a block of concrete. Concrete weighs 151 pounds per cubic foot. So now we're out there doing math. I guess we pretty well got used to doing that. So one of the line items in our inspection report is the known weight. And the weight that we're picking up is the weight of the counterweight or the load block, whatever it is that we're picking up for a block of concrete. We identify what it is. That weight plus the weight of the rigging, plus the weight of the load block, if that's what we're using. In some cranes, you have to calculate the weight of the rope that is coming down from the ship. So we add all of that up as our test weight, and then we go forward. Now sometimes we get into situations where a test load is unavailable, and it has come to pass where we have tied down to an immovable object and put a dynamometer in the middle and pulled what we call a constrained load. It's not a dead man, it's a constrained load. And we test the crane that way. It's a valid test. It's not something that we've done often. The dynamometer, we put that between the water bag and the crane hook. We use the water bag as well to weigh what's in the water bag. I don't understand what this means. I'm passing by. Okay, so the accuracy of the load indicating system is to be such that indicated load is not less than 100% of the actual load, nor more than 110% of the actual load. And standards don't require you to load test beyond 110%, unless it's a maritime crane. I truly don't understand how that happened, because mobile cranes don't do well once you get beyond that 110%. That's really pushing way to the limit. I don't know that it makes them safe. I love the fact that some crane manufacturers took the time to measure how far it is from the center of the rotation bearing to the back of the crane itself. So, because there's not always a place to hook in to measure from the center of the bearing, you can always hook onto the back of the crane. So, we use their calculations. I think it's a nice thing that they do. Now the boom angle is measured on the boom itself. There is typically a black box, and inside that black box is a pendulum, and it's usually oil filled so that the pendulum isn't shaking all over the place. And the pendulum is attached to a potentiometer. Potentiometer is a variable resistor. So as the potentiometer, the pendulum moves, it changes the resistance through the potentiometer, and that reports back to the LMI, which calculates what that particular resistance is in boom angle. It's a pretty slick system. The boom length is the same deal. They have a wire running down the boom, and it's pulling on another potentiometer inside the reel. That's sending that same type of signal back to the LMI. They get even slicker than that as time goes on, by the way. I'll look into it. Now, the accuracy of the boom, the accuracy of the boom length has to be plus or minus 2%. That's from SAE. All right, so that we use that in our inspections. So here we go. Test one. This will be interesting. So I already stated this, right? The object of test one is to confirm that the LMI is doing its math. So the one thing that we measure first is the radius, because that's the calculated number. And everything else, I already covered all the rest of this. Part B of the load test, like I've already covered as well, is the shutdown test. Part one is just to determine that it calculates everything properly. Part B is the shutdown test. And this is what the test sheet looks like. This is actually our old test sheet. So we use 3 minutes as a guideline. And what that means is we put the load out, and then we measure the height, and we leave it for 3 minutes. And then we remeasure the height to make sure nothing's moving. So then we compare all of the numbers and make sure that the LMI is seeing everything properly. If it does, then we go on to test two. Now test two is our shutdown test, like I said. All right, and we're gonna run this crane out to 100% of its capacity. Now the only time that changes, some manufacturers, I know Grove does this, will set their shutdowns at 104%. It's not illegal. The reason they do it is for bounce by. If you're running the crane quickly, you're going to get dynamics with the load. So they don't want it to shut down right at 100%. If there's only, it's merely dynamics that is pushing it higher. So they'll run up to 104%. So with the test tube, we're going to measure the radius, right? And we're going to measure the height of it again, same deal. And we're going to make sure that it doesn't move at all. And this is the same thing, we're going to fill out the same form for test 2. So in our documentation, we're going to make sure that, first off, the owner of the crane is attached to this inspection form. The manufacturer, model, serial number, the LMI manufacturer, because that's not always made by the crane manufacturer. I'm going to say most cranes have a third party that has made the LMI. The crane configuration at the time of the test, and the statement that the system either passed or did not pass this test. And then the inspector's name and the date goes on. And with our program, the inspector's name and date and location is geolocated. So we don't have to worry about somebody doing the inspection from Joe's Bar and Grill. I've been to Joe's Bar and Grill. So if you want to see how we do it, you can snap this QR code. Does everybody have a smartphone? I think in this stage, everybody does. You can take it for a test drive. We've set this test drive up so that even when you leave here, you can log in and see all of the different types of inspections that we have. You can run and perform an inspection. I'll give you a little, just a Reader's Digest version of this. We have this inspection form set up by the standards. And also by some of my experience with some of the accidents that may be a liability issue. So we put that in the inspections. So you can go in and pass and fail. You can take pictures for each line item. So if you've got a problem that you've detected, you can fail it and then take a picture. It goes right on that line item. Everybody got it? Yep. Okay, good. We'll move on. Oh. Okay, moving along. I wanted to share a couple of these. How did this happen with you? And here's the question: how did it happen, and how could it have been prevented? That's the most important one. And what kind of damage should you, the inspector, expect to find? Number one, this is a wallboard truck, and they are delivering wallboard. And the last lift coming off the truck was getting set on the ground, and then this happened. I went to investigate this accident, and it was actually pretty simple. What else we got for pictures? That's the better picture of how the truck ended up. Broke the outrigger off, And after looking at that, it was a fresh break, so there wasn't a previous problem. It would have been indicated by rust where it broke, for instance, and there was none. They had, without a doubt, too much of a load. Now, this crane here isn't counterweighted, right? Its counterweight essentially comes from what's on the bed of the truck. The wallboard's very heavy. So the operator of the truck needs to know the weight of a lift. And in this case here, he just went too far. So that was the broken outrigger. They blamed the outrigger for it, but no. It wasn't the outrigger that gave way that made this happen. This happened that made the outrigger give way. And there's a picture of it. It was like I say, it was a fresh break. So the question is, how could this have been prevented? Because every accident is preventable. I can assure you that in my experience, in every accident that I've seen, they were all preventable. So how could this one have been prevented? What component was missing that made this accident happen? Anybody?
Not following the road chart.
Not following the load chart. Yeah. It boils down to training, really. There's the owner of the crane or the company has a requirement to train his people, or her people, as the case might be. Right? And that's where this fell apart. It was all about training. I've run into so many accidents where the operator was running by the seat of their pants. I think that term actually came from the crane business. You know, when the crane started to go light, right, your seat come up, that way you knew that you were nearing the end. I don't know for sure where the term came from, but it's certainly applicable to the crane business. Yeah, this one here, is, in my opinion, is all about training. Now, from the employer, because I did investigate this, the operator was experienced. Does that preclude training? No, it doesn't. I went on another accident that I don't have pictures for here, where lattice boom crane, they were taking up seawall, and the operator made a mistake, and the boom broke, and the seawall went into the ocean, and the boom went into the ocean. And I got there, and I started interviewing him when I first got there. And I asked him, you know, how long have you been running cranes like this? And he said 22 years. And he was a union crane operator. Union crane operators are usually pretty good. And I said, well, what did you have for a load? And I saw the boom angle, and I knew the length of the boom, so I said, what did you have for a load? And he said he didn't know. He says he was supposed to be removing 10 feet of seawall, but this particular pick was 11 feet. So we went into the crane, and I said, let's look at the load chart. He's a 22-year veteran crane operator, and he didn't know how to read the load chart. And this is a very simple load chart. It was the one that I had the picture of earlier. He didn't know how to read it. So assuming that experience equals training is a bad assumption. So that was the cause of the accident, right? The overload of the crane. I calculated it out. He was at 185% of his chart at the point when the boom broke. The boom did pretty well. That boom looked like you threw a bomb at it. It blew up. Okay. moving on. And this is from the operator. I've always operated it this way. And again, that we're talking seaweed pants, because that's how he was operating. And I don't know why, but he was surprised. He said all the picks are going smoothly. I don't know why the last one didn't. So this is my observation, which I've already covered with you. So I wrote this up, and they were unhappy with what I wrote, and this happens to me. I lose customers like this, I have to admit. They didn't like the way I had written it up. I said, well, it's what I saw. It is what it is. Number 2.
Excuse me, is there a standard safety factor in the load charts? Is there a standard safety factor in the load charts? In other words, if it says they can pick up 100 pounds, is the actually tip point 125 pounds, like the 25%? Is there any standard safety factor, or is it dead on? Is the 100 pound? Okay.
Yeah, and when we do a load test, we do it that way, you know, dead on. Interesting story. I was asked to do a maritime load test, which is done at 125% on a Grove GMK, which is a very high-tech crane. It's Grove's most high-tech crane. And typically they're built to pick up just what they say they're going to pick up. You know, 'cause again, when they make the crane, they want to make the crane weight as light as they can while picking up the most weight that it can do. So they have to sacrifice that strength in the boom in order to keep the weight down. So when they asked me to do a maritime inspection, I said, you can't do that with a Grove. It frightened me. And he said, well, we bought this crane from Grove and they told us we could use it this way. So I called Grove and I talked to the head of safety, who was a personal friend, and I said, I got this GMK and they want me to run maritime 125 on it. And he said to me, no, you can't do that with that crane. I said, okay. I said, they bought it from you and you guys told them he could. And he says, give me the serial number. So I gave him the serial number and he said, I'll call you back. And he did. He called me back and he said, okay, here's what you got to do, Jay. He's whispering in my ear. You've got to raise the load real slow, no dynamics. I said, that's your answer? They want to sell cranes, of course. So that was the answer. I was nervous about doing that because I knew that that boom doesn't typically take that much of an overload.
Jay, why being maritime, would that make a difference?
That is a great question. It's because somebody on the maritime committee said, our cranes need to be tested at a higher rate to make them safer. How do you think that makes them safer? I don't know either. but that's the way that it is. If it's maritime, they're going to run that 125% load test. I can't explain it any better than that. I really can't. This was an interesting accident. This was a re-railer crane. A re-railer crane is designed to pick cranes up off of the tracks when they get derailed, put them back on the tracks. So this is a 130-ton wrecking crane, if you will, and it's designed to go on the tracks to pick up a crane that's derailed. So the driver's instruction was to take this crane and move it from this summer yard over to the yard that is just off Sturm Drive, Boston. Everybody familiar with that, Sturm Drive? Right. It was probably built at a time when people were running Conestoga wagons in the bus. It's got some very low bridges. So there's warnings trucks not to go on Sterling Drive. But the yard is on the on-ramp to Sterling Drive, and then you have to take a right before you get onto Sterling Drive itself to get into that other rail yard. So the driver was taking the crane over there. The crane measures 13 feet 6 inches tall. And he got onto the on-ramp, and there's a sign there with chains hanging from the sign, and that says, bridge too low, all trucks turn off here. Well, he wailed that sign when he went on to Storrow Drive, and he got down to the first bridge, which is 12 feet high. An amazing fate of physics, he got this 13'6" truck under the 12-foot bridge and out the other side. And how did he do it? Well, speed, number one was the fact. Not that he was over speeding, but he needed some velocity to make this happen. And he broke the frame in half. The whole truck sunk because the frame broke. Is a picture of the welds on the frame. The frame is 18 inches tall. So we managed to snap the frame in half. And then, there's more pictures of the frame, cleared all of the upper works. There was shivs and ropes on the top there that lifted the boom, cleared all of that off of the top. This is where the shivs used to be. So everything got wiped off the top. When I got to the yard, they were telling me that to get it off of Storrow Drive, they had to chain the front half of the truck to the back half of the truck because there was nothing left holding it together. And then they had to flat tow it very carefully off of the next exit. So they were fortunate that they could get it to the next exit. So the driver had been with the MBTA for 6 months, and it was a simple task, right? Storrow Drive is notorious. In fact, now they have a term in Boston called getting Storrowed. It usually happens when college students are moving into Boston that have never seen Storrow Drive before. They go rent a van and to move their stuff in, and then they hit these bridges, and they call it getting Storrowed. So the operator admitted that he missed the cut off. There's really nothing more that he could say. So this was from my observation. The crane was 13'6". The bridge was 12 feet. The boom lift works were all laying on the deck of the crane. And the frame snapped at the butt welds. The middle of the frame itself snapped in half. That's how I written it up. This was a fun accident, and another one where I lost a customer. The customer was hired to take down some trees because the homeowner had just replaced the roof, and he didn't want the sap all over the new roof. So that was the job at hand. So he was putting his climber up into the tree with the crane. This is a common and growing way to manage doing tree work. So he was putting his guy up in the tree, and they cut the top of the tree off, top 25 feet of tree. And in the tree business, you've got to be very careful because there's no indication as to what the piece of tree that you're taking down weighs. And once it's cut, you own it. So it's a different way to use a crane. There is charts out there to calculate the weight of the tree, and they're pretty good. and if you're smart, you'll be using them. Well, what happened here is like the seesaw. The piece of tree that was cut was too heavy for where the crane was. And the crane did this. And I don't know if you can see it from this angle. Do I have a better angle on it? I don't think I do. When the crane went up like this, it went over and the outrigger went through the roof of the house, the roof that they just put in the house. The operator, who's the owner of the company, went out through the windshield of the crane. So when I'm interviewing him, when I got there, his face is all bloody because he went through the windshield. He told me, he says, geez, I was so lucky able to swing the crane away from my climber who was still in the tree, because if he had hit the climber with the boom, he probably would have killed him. So I said, well, let me run my investigation. So the first thing I do, because I want to know where the crane was in this configuration, is I measure from the center of rotation down to where the crane landed to get my first measurement, and then I measured out to the vault where it ended. And I calculated where he was in his load chart, because he had a what's called a green log chart to determine the weight of the tree. So I calculated by the weight of the tree and where he was, and I said to him, I said, my first calculation tells me that your boom couldn't possibly have been that far out. He said, no way. How did you get it out there? He says, well, I put it in override. Now, all cranes have the ability to override the LMI, so they can go beyond what the chart has. And why would that feature be there? Because it's there on all cranes. Why do you think that feature is there? Right, so you can go way into overload on the crane. The main reason is to service it. You need to be able to lay that boom down outstretched so you can service it. So the LMI isn't going to allow that. You're not going to be in a good place in your chart. And he wasn't in a good place in his chart. He had to go, because I measured out where he was, and I said, you're at 115% of your radius. And that's why I said, how did you get that? And he said, I put it in overload. Well, an override. Override isn't a get out of jail free card. It's made to be serviced. So I wrote my notes for the report, and he said, can I use your report? Because OSHA came out and had written them up. And I says, well, in my report, if you give this to OSHA, I think they're going to have you arrested. I says, you put your man in peril. And I says, I can't stand behind you. What you did was wrong by every facet of crane knowledge. So at any rate, I lost the custody. Any questions about that? It's actually pretty simple. Yes?
The LMA reports are pretty impressive, those things.
Yep.
Because you're actually going to print out like an Excel spreadsheet.
Yes, and some of them, they're like a black box.
It's going to tell you the date and time and
Yep.
how many times that operator overrode that specific machine for that specific reason.
Yep.
Then you can send it back to the manufacturer and have them summarize the dates.
Yep.
They'll
Yeah.
tell you that, and I've had it happen where the operator overrode the system 27 times a Monday.
Yeah. Can you imagine? I know. I'm working on a case right now where we're running all the black box numbers, and I don't know if there's going to be an arrest in it. There should be. It was a pretty egregious thing to do as a crane operator. But yeah, some of the newer cranes are very good. They uplink, satellite uplink. Yeah.
Jay, does the LMI tell you the load you have on there, or just the radius, or the distance?
It tells you
have
the
from
load.
pin?
Yeah, but you've got to remember that it's a calculated number, and you have to run by the load chart, not by the LMI. You can use the LMI to confirm what you know for a load. That's really, when we teach, that's how we teach it. Use the LMI to confirm what you already know. It's really important. It's an electronic piece. Things can happen to make it go up. You know, I know that firsthand, I can assure you. Now, that's a good question. Any questions? I think this is the end of the presentation. I think I did a pretty good time, didn't I? Yes.
So as a general contractor, we hire, the crane company to come out.
Yep.
If I'm going out there on the crane pick, what should I be looking for or asking from them so that I can make sure I'm receiving?
Okay, as a general, first thing you want to have is a copy of the inspection itself.
So I can ask for that when I get there?
Yes, you can demand it. That is typical. You demand a copy of the inspection and go through to see if there's any deficiencies. You can demand a copy of the daily inspection or monthly. Okay. In construction, there's a requirement for monthly, but by the manufacturer, if there's a daily inspection and there's an accident, if there's a daily inspection checklist in the manual, for instance, because the newer cranes are up there, then you can ask for a copy of the daily inspection. And if it's in print by my yardstick, then that means there's a requirement for it to be documented. Okay. Now, we do our inspections, and I hope everybody got the QR on this. We do our inspections electronically, all right? I think I was the first inspection company to actually database inspection, because I've been doing that since the turn of the century. Weird to say that. But now I hired a company to bring us up into even a better place. So everything's on a cloud. An operator can do their daily inspection on their cell phone and submit it. When it gets submitted, they have the ability, like if our sticker is on the crane, anybody can walk up, snap that. It's going to tell you what the crane is. It's going to tell you when it was inspected, by who. Then there's a link on there to request a copy of the inspection. That request will go back to the administrator, whoever the administrator is for that crane. And then they should send you a copy of the inspection. We're hoping is going to bring us up into the next century. That's how we work. We've been using and making every little update that we can to this program for about 2 years now. I, in fact, hired the engineer that wrote the program, so she's on staff, which is a very, very good thing. So it's proprietary, but she has developed a test drive, so you can go in and perform an inspection. When you submit it, it's got to get erased, but you can go and do another one. This is something that we're going to offer to the public very soon. We're finishing up an app so that it can be used even when there's no cell service or internet service. Did I answer your question?
Yes.
Okay, good. Any other questions? Well, I thank you all for coming, and I inspire you to take the test drive. It might be fun.
Thank you.
Thank you.